A ball is kicked with an initial velocity of 16 meters per second in the horizontal direction and 15 meters per second in the vertical direction. So here is a ball. When it is kicked, of course, it has got components. We have got the velocity in the x, that's a horizontal component, which is 16 meters per second. Then you also have the vertical component, which is 12 meters per second. At what speed does a ball hit the ground? So the first thing we need to know is that the velocity in the x at the beginning and at the end will be the same. So even at the end, the velocity index will be 16 meters per second because velocity in the x doesn't change at all. And then now we need to find the velocity in the y. Now for a question like this, because you're talking about a level ground, the velocity in the y that you started with, every time you throw something, the velocity at this point in the y is going to be the same as the velocity at this point in the y. The only difference is that they've got opposite signs. So it will actually be negative 12 meters per second because at the bottom here, it's going to have the same velocity. You can actually calculate that if you do want to perform a calculation. You first find the time it will take for the ball to reach the bottom. When you find the time, and then you come now to find the final velocity. But it's not necessary. So now that we know the both components, how long for how long does okay, so I've got part two of the question. For how long does the ball, oh, we've not answered one. So at what speed does the ball hit the ground? The speed at which it will hit the ground is going to be the same as the speed at which the ball was released. Okay. In the x component, you have got a velocity, and in the y component, you have got a velocity. Just take v being equal to vx squared plus vy squared and then square root. So that is this 16 squared plus negative 12 squared and then square root that. That is going to give you a 20. For how long does a ball remain in the air? So you want a time of flight. A lot of formulas that you can use. You can say height is equal to ut plus half gt squared. But for majority of the question we've been using is the point of the fall has been lower than the point where you started. But here the point of the fall and the point where you started is the same. So if you find the height is going to be 0 because the final position and the initial position is the same. So 0 is equal to u, initial velocity in the y, right? This is a 12 multiplied by t. Because we went upwards, g is going to be negative 9.8 and then squared. So b 0 is equal to 12t minus 4.9 t squared. Take the t, you can actually take both of them this side. 4.9 t squared minus 12t is equal to 0. Factorize out t. 4.9 t minus 12 is equal to 0. Here equate them. T is equal to 0 or 4.9 t minus 12 is equal to 0. 4.9 t is equal to 12. Divide both sides by 12. T therefore is going to give you 2.44. 2.448. So you can see that the only point when this ball is at this level is at the beginning and after 2.48 seconds. I could have also said V is equal to U plus GT. First, I find the time to reach the maximum point here. The final velocity at that point, of course, is 0. Initial velocity in the y is what? A 12. And then g is negative 9.8 multiplied by t. So that will be 9.8 t is equal to 12. So find the time to reach the maximum point. That is just a 12 divided by 9.8, which is a 1.224489. And then this is going to be the same time it will take for the projectile to move from the maximum point to the bottom. So just multiply it by 2. When you multiply by 2, it will still give you 2.44. So that's another method you can use. What maximum height is attained by the bow? The maximum height, we can say 2gh is equal to v squared minus u squared. V2 g is 9.8 and it's actually negative because we are going upwards. Final velocity is 0 in the y at the maximum point. The initial velocity is 12. Square that. Negative 19.6 h is equal to negative 144. Divide both sides by 19.6. That will give you 7.3469 meters. That's the maximum height.